Hi, and welcome to a friendly introduction to recurrent neural networks. My name is Luis Serrano, and I work at Udacity. I teach machine learning and artificial intelligence courses there. Here's actually two pictures of me. The first one is on the first lecture of a machine learning class, and the second one is on the last lecture of that same class. So you gotta watch out. That's what machine learning does to you. But anyway, I'd like to thank everybody for the comments and the messages after my previous videos. A lot of suggestions were received, and one of them was recurrent neural networks. So that's why I decided to make this video. So first of all, credit when it's due. I had a lot of inspiration from a video from a friend of mine, Brandon Rohr, who has an amazing YouTube channel and really good machine learning videos and a blog. So you should totally check it out. And so the example is inspired by one of his examples, and it goes like this. You have a roommate, which is the perfect roommate. And why is he the perfect roommate? Because he cooks every day. And he cooks three types of foods: apple pie, a burger, and chicken. And he has a rule for what he cooks. So he first looks outside at the weather, and it can be sunny or it can be rainy. And if it's sunny, he cooks apple pie because he's happy. And if it's rainy, he cooks a burger. So this scenario can be easily modeled by a very simple neural network. If you don't know what a neural network is, I recommend you this other video that I have on my channel. It's called A Friendly Introduction to Deep Learning and Neural Networks. You should check it out, and that'll give you an idea of what neural networks are. So this would be a very simple neural network. A neural network has an input and an output. And so in this case, the input is, for example, a sunny day, and the output is an apple pie. Or if the input is a rainy day, then the output is a burger. So let's do some math. And for math, we're going to introduce vectors. So we're going to represent the food by some vectors and the weather by some other vectors. So the apple pie is going to be the vector 1, 0, 0. The burger is going to be the vector 0, 1, 0. And the chicken is going to be the vector 0, 0, 1. So as we have three possible foods, we represent them with vectors of length 3. And the weather is going to be represented as follows. The sunny day is going to be represented by a 1, 0 vector, and the rainy day is going to be represented by a 0, 1 vector. And so what the neural network does is, if it receives the 1, 0 vector corresponding to a sunny day, it returns a 1, 0, 0 vector, which is an apple pie. And if it receives a 0, 1 vector corresponding to a rainy day, it returns a 0, 1, 0 vector, which is the vector corresponding to a burger. And this neural network is actually just a very simple matrix. So this matrix works like this. And if you're not familiar with or if you need to brush up on matrix multiplication, there's a lot of videos that I recommend. In particular, Khan Academy has some pretty good videos. But this is how it works. I take my matrix, and if I multiply it by the vector 1, 0 corresponding to a sunny day, my result is the vector 1, 0, 0 corresponding to an apple pie. And if I take the vector 0, 1 corresponding to a rainy day, the answer is the vector 0, 1, 0 corresponding to a burger. So this neural network is just a linear map that sends the sunny day to an apple pie and the rainy day to a burger. If you're used to seeing neural networks not as a matrix, but as a bunch of nodes with arrows, this is it. This is the matrix on the left is turned into the arrows on the right. As you can see, the dark arrows are labeled 1 for the ones in the matrix, and the light arrows are labeled 0. And how it works is that if you take the vector, for example, corresponding to a sunny day, which is 1, 0, then this vector goes inside the first layer of nodes, and then the value in the node gets multiplied by each of the edges and then added in the right. So this becomes this vector 1, 0, 0, and you can check that. And that's actually equivalent to matrix multiplication. And that's why neural networks are really representing a bunch of matrix multiplications. And so here you get the vector 1, 0, 0, which is the vector corresponding to an apple pie. And you can check that if you input the vector corresponding to a rainy day, which is 0, 1, you're going to get 0, 1, 0, which is corresponding to a burger. Okay, so that was a simple neural network. Now let's go to a slightly more complicated problem. Let's say we still have the perfect roommate. He still cooks every day, but now he doesn't base his cooking on the weather. He's actually very organized and very methodical, and he just cooks in sequence. So one day, if he cooks an apple pie, then the next day he cooks a burger, and then the next day he cooks a chicken, and then the next day again apple pie, and then burger, and then chicken, and then so on and so on. So we can always tell what he's going to cook based on what he cooked the day before. So an example is if on Monday he cooks an apple pie, then on Tuesday he cooks a burger, then on Wednesday he cooks a chicken, then on Thursday an apple pie, then on Friday a burger, then on Saturday a chicken, and so on and so forth. So this is not a normal neural network anymore. Now it's called a recurrent neural network because now, well, in this case, there's no input for the weather, so the bottom arrow doesn't come from anywhere, but the output goes back in as input. So this apple pie over here, if he did an apple pie yesterday, then this comes back as input, and then the output is a burger. So that means today he'll cook a burger. And if today he'll cook a burger, this comes back as input. Chicken is the output, means tomorrow he'll cook a chicken, and so on. Then we input the chicken, etc. So the neural network really looks like this. The input is the same output that came out from the previous one. So let's recall that these are the vectors for the food, which are 1, 0, 0 for apple pie, 0, 1, 0 for the burger, and 0, 0, 1 for the chicken. And let's make a neural network that will do the job. And that neural network is going to be this matrix. Also very, very simple matrix. Because what this matrix does is the following. If we multiply it, for example, by the vector of the apple pie, if you take a look, we're going to get this vector, which is the vector corresponding to a burger. If you multiply the matrix by the vector of the burger, you get the vector of the chicken. And finally, if we multiply the matrix by the vector of the chicken, we get back the vector of the apple pie. So this neural network is simply a linear map that takes the apple pie and maps it to the burger maps it to the chicken, and the chicken maps it to the apple pie. And it's simply this matrix. But as before, if you like neural networks more as a diagram with nodes and edges than as a matrix, this is how it looks. And the way it looks is the following. If I have, for example, my vector corresponding to the apple pie, these entries in the vector go here. And now I haven't drawn all the edges, but I've only drawn the edges that have label 1. And the edges with label 0 are just not drawn. So this matrix multiplication is exactly doing this. And now we get the vector corresponding to a burger. And you can always check that if you put in the vector of the burger, you get the chicken. If you put the chicken, you get back the apple pie. So this is how the neural network looks. But now let's take a look. The 3 nodes on the right are the output, and they're food. But that output comes back in as input. So really, this is how the neural network should look, right? The 3 entries, the vector corresponding to the output goes back and feeds into the input. And so that's why it's called recurrent, because the input is not just one thing. The input comes from the output. So that's it. That's a very simple recurrent neural network. So let's look at a more complicated one. Let's go back to the perfect roommate situation. And now his rule for cooking is going to be a combination of the 2 previous rules. So he's still very methodical and he still cooks in sequence, apple pie, burger, chicken. But his decision of what to cook is going to depend on the weather as follows. If it's sunny, he's going to go outside and enjoy the day, and he's not going to be cooking, so he's just going to give us the same thing as yesterday, so leftovers. And if it's rainy, then he stays outside, he has nothing to do, so he cooks the next dish on the list. So if it's sunny, we get the same thing as yesterday. if it's rainy, we get the next thing on the sequence. So here's an example. Let's say on Monday he made an apple pie. And so on Tuesday we check the weather and it's sunny. And if it's sunny, then he doesn't cook anything new, so we get an apple pie. I hope it's not a confusion that I put the sunny weather for Tuesday under Monday, but it's just for diagram purposes. So on Wednesday, checks the weather. If it's rainy, then he stays home and makes something different, so a burger, because it's the next thing on the list. And if on Thursday it's rainy, then again, he makes chicken because he stayed home and cooked the next meal. And if Friday is sunny, then he goes outside, doesn't cook anything new, so on Friday we get chicken again. And if on Saturday is rainy, he cooks the next dish, which is an apple pie. And if Sunday it's sunny, then he cooks an apple pie again, and so on and so forth. So this is how this recurrent neural network looks. Now there's an input coming from underneath, which is the weather, and an output, that is the food, that comes back as input. So check this out. If yesterday's food was apple pie, and today the weather is rainy, then these two things feed into the neural network, and the output is a burger, because in a rainy day he would cook the next food, which is a burger. So again, let's look at the vectors. So recall that the apple pie is vector 1, 0, 0, burger is 0, 1, 0, chicken is 0, 0, 1, and the weather vectors are length 2, because there's just two of them, and they are 1, 0 for sunny day and 0, 1 for rainy day. So I'm going to show you the neural network not as a matrix, because now it's more layers, but as a bunch of matrices and some maps. So here are the two matrices. One is called the food matrix and the other one is the weather matrix. And then we add them and then we merge them on a kind of nonlinear operation. I'm going to show you all these steps one by one. So let's start by the food matrix. So this is how the food matrix works. As you can see, it's a 3 by 6 matrix, but I've kind of artificially cut it into two 3 by 3 matrix, so it looks like a concatenation of them. And if I multiply the matrix by the vector representing an apple pie, this is what I get. I get a concatenation of two vectors where the top vector is the same thing that came in, because as you can see, the top three rows of the matrix are the identity matrix, and the bottom three rows of the matrix are the food for the next day, so the burger. For redundancy, let's look at another example. If I multiply this matrix by the burger vector, I get this, which is a vector concatenation vector of the burger, which is the food for the same day, and the food for the next day, which is a chicken. And finally, if I multiply the matrix by the vector corresponding to a chicken, I get the vector concatenation of the vector corresponding to the chicken, which is the food for the same day, and the apple pie, which is the food for the next day. So what the food matrix does, all it really does is it takes your vector for today's food and it returns the vector for today's food and the vector for tomorrow's food concatenated. That's all it does. Now let's look at the weather matrix. So the weather matrix is also a concatenation of matrix and of matrices, where the top matrix, it just has 3 ones on the first row and the bottom matrix has 3 ones on the second row. Check out what this does. If I take the weather matrix and multiply it by the vector corresponding to a sunny day, then I get 3 ones on the top and 3 zeros on the bottom. So I get basically a vector that tells me that this is the same day. Because there's ones in the same day and zeros on the next day. And if I take it and multiply it by the matrix by the vector corresponding to a rainy day, I get zeros on top for the same day and ones on the bottom for the next day. So this weather vector is kind of telling me, should I cook today's food or should I cook tomorrow's food based on the input. And so now some magic happens. We add these two and we should get a clear signal of what we should cook the next day based on what's the food for today, what's the food for tomorrow, and should we cook the food for today or should we cook the food for tomorrow. So this will be much more clear in an example. So the example is yesterday we cooked an apple pie and today the weather is rainy. So here is the result of when we multiply the food apple pie vector by the food matrix. So we get the food for today and the food for tomorrow. This is a result of multiplying the weather matrix of rainy day by the weather matrix. So it tells us a signal of we should add the next day part of the vector. And if we add this 2, we get this vector. And notice that the largest entry here is a 2, and the 2 hints of a burger because the vector for a burger has this 0, 1, 0. So that we're going to try to extract that 2. And for extracting the 2, we use the merge map. But notice that this is very special. The first part, the first summand, tells you what's the food for today and what's the food for tomorrow. And the second summand kind of tells you which one to pick. Should we go for same day? Should we go for next day? So those two decisions together form the decision of what to cook the next day. And so just to wrap this up and put these two together into the burger vector, I'm going to now show you the merge map. The merge map, what it does is, well, first of all, it uses a nonlinear function that turns this vector into this vector. So it basically takes the largest entry and turns it into a 1, and all the other entries and turns them into a 0. If you experience with neural networks, you can think of these nonlinear maps as one-hot encoding or as a combination of some linear map and a sigmoid. But that's not important right now. And then what the merge map does is it takes these vector formed by the top 3 entries and the vector formed by the bottom 3 entries and just adds them. And we get the result, which is a vector 0, 1, 0, and that is a vector corresponding to a burger. And that's the answer, because if I take an apple pie and a rainy day, I get a burger. If you like to see this arrow, this merge map as a matrix, it's this matrix. Because as you can see, if I multiply this matrix by a concatenation of 2 vectors, I get the sum of them. And again, if you like to see neural networks not as matrices and nonlinear maps, but as traditional edges and nodes view, this is how it looks. So it's got a food section, a weather section, an add section, a nonlinear section, and a merge section. And it goes as follows. If I input my vector for the apple pie and my vector for the rainy day, the vectors go into the nodes like this. And the matrix multiplication, as you can see here, I have edges that are labeled 1 are drawn, and the edges that are labeled 0 are not drawn. And a matrix multiplication is exactly putting the values through the edges and multiply them by the weight of the edge and adding them. So I get this for my results of my matrix multiplications with the food matrix and the weather matrix, and then I add them, and addition is given by just adding these things in the arrows, so I get this. Then I apply my nonlinear function that takes the highest entry and turns into a 1 and everything else into a 0, and I get this. And then my last matrix, which takes the vector and adds the top 3 entries and the bottom 3 entries, gives me this, and boom, I get the vector corresponding to a burger. So that's how the neural network looks. Now, the word recurrent is important there. Notice that these 3 nodes correspond to the food coming in, and these 3 nodes correspond to the food coming out. So really what happens is that the output, or the food coming out, feeds back into the neural network as input. So really, this is how the neural network looks. See, this vector of length 3 goes back into the neural network and feeds in as input. That's why it's called recurrent neural networks. And recurrent neural networks are super useful in many things. In particular, they're very useful when your data is sequential. So whenever your data looks like it forms a sequence, and whenever the next data point depends a lot on the previous ones, then recurrent neural networks are good. An example of this would be stock prediction, right? Because in stock prediction, the price for the stock for today depends a lot on the price yesterday and the price 2 days ago. Things like sequence generation. So anywhere where your data follows a sequence, like text generation, if you're trying to guess the next word in a sentence, like when you're typing on your phone and the phone guesses the next word, that depends a lot on the previous word and on the word before. or even for letters, if you're trying to guess the next letter. That depends a lot on the letter that just happened. So things like voice recognition is used when you're trying to guess a string of words. Then you have the sound coming in, but you also have the previous words. So then you have two places where your information comes in order to guess the next word that you said. So that I hope gives you an idea of how important recurrent neural networks are. But now the next question is how to train a recurrent neural network. And I won't get too deep into this, but it's the idea is something like this. Our neural network really depends only on these parameters, right? These are the right weights that make our model great. And the way to train them is to start with some random weights. So imagine if A, B, C, D, E, F, and all the way to capital V are just random numbers, and we train them using gradient descent. So if you want to brush up on gradient descent, or if you haven't seen it, I again recommend the video that's on my channel called A Friendly Introduction to Deep Learning and Neural Networks. What it does is you have some parameters and you have an error given by your data. So you fit in your data to your neural network and it gives you a big error, and you do steps to reduce this error slowly. So the error is represented by a mountain called Mount Everest, and you descend this mountain in order to reduce the error. Of course, for recurrent neural networks, it's not going to be the same error function, so it's not Mount Everest. Now it's Mount Kilimanjaro. That's going to be a new error function, and descending from the mountain is the equivalent of reducing that error. So that's all, folks. I hope you enjoyed this video as much as I enjoyed making it. If you liked it, please subscribe. Please hit like or share it. And feel free to comment if you have any questions. I love reading your comments. I try to respond them to most of them. And if you have suggestions for what is the next video you would like to see, or if you need any clarifications, or in general want to chat about machine learning, feel free to throw in a comment. These are my coordinates. It's my LinkedIn, my Twitter. Feel free to subscribe to me on Twitter, and that's the link to the YouTube channel. And finally, yeah, if you like this course, I have a few courses at Udacity. You should feel free to check them out. So thank you very much, and see you in the next video.